DataCon LA 2021. Welcome to the Data Engineering track. My name is Eli, your host, and our co-host today is Lori. We will be moderating the chat and Q&A for you during this session. Today we have our guests, Cahlen and Dave, who will be presenting building production data pipelines using test-driven development and pair programming. Cahlen Humphreys is managing principal at Infuse.io, Inc., a boutique software development professional services company that focuses on big data, distributed environments, and high-speed data processing. Dave is Director of Engineering at Infuse, is an experienced software craftsman based in Boise, Idaho. He is passionate about software culture and emerging technologies and is well-versed in a variety of modern processes, tools, and programming languages. Without further ado, I'll hand this over to the speakers. Thank you for being here, Cahlen and Dave.
No, thank you, thank you. Let's go ahead and see if we can get the screen share set up real quick. Excuse me. Great. So no, thanks for attending the talk. I was really excited about this year because, again, like we were talking earlier, I'd been to a DataCon a couple of years ago on USC campus, and I was so intrigued because I saw different people at different levels in their journey with data, from people straight out of like undergrad and grad school to working professionals to leadership as well. So we tried to tailor this around to hit those certain points. And like you described earlier, the one thing I kind of missed out on in person was doing live coding, right? So that's what we really wanted to do here, because I like to see people mess up, right? I like to see what can go wrong. But in this scenario, we want to show you that too, because that's what pair programming is, and how we solve those things on the fly. So, quick introduction. Very briefly, I'm going to fly through these slides so we have as much time as possible for the code. But like we said, I'm Cahlen Humphreys. This is Dave Miller, and you can go to our website to get more information about that. So, what we mean by production is over the past 6 to 7 years, I'm seeing. I mean, there's trending. We're seeing the merging of a lot of things from software development to data engineering to DevOps. So what we do, at least when we build, back-end data pipelines and processes like that, we're building tons of software, right? However, all of us have, had data engineering positions, especially more traditional data engineering positions, where we're working in, say, SQL Server, Oracle, and then along when time came up, more distributed environments like Hive, and then all the managed services as well. So incorporating those elements into our applications that we write is super important, because the pipelines that we build, if the volume is insane and very large amount of data, then we're not going to have a single application instance of whatever software would be processing that data. We're going to have distributed systems do that. So those fields are merging quite a bit. And then with the managed deployments of it, back not too long ago, we would have to build these infrastructures ourselves, maintain them, or shove them off to a DevOps team. But now with all of the kind of managed stuff out of the box from different cloud environments, a lot of that has actually been pushed down to the developer in a lot of cases. So in this instance, we're going to be running an application in Azure Spring Cloud, which is a service between Microsoft and VMware that allows us to write Spring Boot applications, push them up, and then we have full control over them as far as if we want to scale them horizontally, or vertically, for this matter. We could do both, and a number of other things. So a lot of that, the DevOps portions are kind of moved into cloud environments these days. So all of our consultants in Infuse have a little bit of everything with respect to this stuff. So what is pair programming? It's exactly what you would think. It's two people sitting next to each other writing code. Typically, we're never next to each other in person. We made it this special because we thought, stuff's going to go wrong in a live coding demo anyways, but it can go really wrong if we're both remote on a virtual conference in different states. So we're next to each other, and to be 100% honest with you, pair programming in person is just a lot funner, because then we get to practice what we call ping pong pairing. The driver, in this case, will be writing a test. The navigator implements the code to pass the test, and then we switch positions. Then navigator becomes driver, driver becomes navigator, and so on and so forth. So it mixes up the day all the time. The day goes by very quickly, but we're able to catch lots of different mistakes, and not the complex mistakes, but the simple mistakes. Underscore here, we're editing the wrong file here, we're deploying the wrong thing here. Those things that can be pretty big blockers for us if we're doing solo work are remedied very, very quickly. So a little bit about Infuse before we jump into the demo. What you see today, us working together, this is what we do every day. Typically, it's not with another Infuse person, though, it's with a client engineer. We'll fuse onto client development teams, show them this process, give them a continuous knowledge transfer of best practices with back-end development, how to work with distributed systems, but also how to craft really great software in the process. They give us the ability to navigate the domain, because we can go from industry to industry to industry very quickly over a matter of months, and deciphering things like specific domain acronyms, finding out, who do I have to talk to in security to get port 27 open in GCP or whatever. Client engineers know that structure for us, and they're able to navigate it quickly. So it increases that business agility and decreases the time to value. So test-driven development, again, the 3 tenets we're just going to talk about here. We're going to write a failing test. We're going to write code, only as much code that passes that test. We'll have an opportunity to refactor. We rinse and repeat. In a real sort of scenario, we have a bunch of different tests: unit test, hybrid context test, integration test, end-to-end test. We don't have nearly enough time to do all of those, so we've selected some tests that I think that are best for this example. So before we jump into the demo, we have about 32 minutes left, it looks like. I want to kind of describe what we're doing so that we're not completely blind jumping into it. Now, again, we're doing all this in Azure. We do most of our work in GCP. Datacon was a great example for us to finally get to use something in Azure. Not something in Azure, but Azure Spring Cloud specifically. But again, most of our work is GCP and AWS, the most popularized ones. But we really wanted to showcase this Azure Spring Cloud because it's unique that you get a managed service or a platform that you can deploy super easily and get a bunch of benefit out of it. A bunch of scaffolding that manually building takes forever. So we have a source application that's already up and running in Azure Spring Cloud. It's retrieving a random word in English from just some random API I found every 10 seconds externally. It's taking that piece of data and it's pushing it into an input topic in Azure Event Hubs called input. You can call it anything, but input sounds good for that. Now, what we're going to build is this red box. It's a processor application that we're going to deploy out. It's going to consume those English words from the input events topic. We're going to process that data by using the Azure Translate Service. So Azure Translate Service is synonymous also with GCP Translate. A lot of cloud environments will have translation APIs available. So we incorporate that in this processor because I wanted something other than just string manipulation for a demo. This is more of a real thing, so a little bit more fun. And then we're going to output all of that data into an output topic. But most importantly, we're going to build this processor from scratch. So what do we have to do? Let's run into our demo portion here real quick. And I'm going to open up this guy. We're going to write a Spring application, and to write any Spring application, we always start with the Spring initializer. That's what makes it easy. I'm going to pick a Gradle project. We're going to choose Java, although we have options for Kotlin there. Everything else is pretty much fine. I'm just going to give it a package path use. We'll call it processor. And at this point, we have a skeleton structure that we can download. But we can also add dependencies. So if we wanted to add the externalized config, we could add the config client. We want to add like service discovery and registration stuff, ZipKit, Cloud Stream in particular, because this is going to be a Spring Cloud Stream application. So what we would do is just generate the package and it downloads a zip. In lieu of time, we've already got that file unzipped for us, right? And it gives us this structure. The great thing about the Spring initializer is there's a lot of stuff that goes into Java as far as importing, package structures, everything else like that. I don't want to do that by hand. Start that Spring.io script for that. The default build file they'll do for us, you'll notice these commented out dependencies. Let me uncomment this. These dependencies are really, really nice because they're kind of battle-hardened Spring projects that we just attach into this application. So when we deploy it out into the cloud, we get a lot of good stuff. Tracing, observability, metrics, everything out of the box with no configuration at all. But we're going to run it locally first, so we're going to comment this out. The translation client here that we see is something that we've made. It's a wrapper for the translation service, just to kind of speed this up because we do have that. So Spring Cloud Stream, we want to first write a test, right? Test-driven development. So let's go ahead and make a package in our test. Oops, I didn't break everything like that. We're going to make a package. We'll just call it functions. And the reason I'm going to call it functions is because since we are using Spring Cloud Stream to ingest from the input topic and output to the output topic, the programming model for that requires that we have a function that will input and output, right? So that's what we're first going to test. We're going to call it, we'll call it processor functions test. We have a very bare metal kind of test class here. The first thing I want to do is I want to tell the Spring framework that this is a test for Spring, right? So I'm going to annotate it with Spring Boot test. And the next thing I'm going to do is I'm going to inject the class I want. Now that class doesn't yet exist, so we're going to see a lot of red underlines real quick in IntelliJ, which means IntelliJ is really doing its job. Good. So processor functions, this is going to be a class that we're going to test, so we're going to bring that in. And then I'm also going to mock a class, and the class I'm going to mock is a service class. The service is going to be called from the function, right? So when you think about the function, if we write like an MVC application for Spring, we want everything to go to a service. We don't want a bunch of logic in that controller, similar to our function, right? So we're going to create this thing called translation service, and we're going to mock the behavior in our test. So to define our test, we usually, the first parameter we give is the name of the method we're going to test, and then we give a descriptive description. And these are very, very long, but very, very helpful. So say, given English word, then return.
And while he writes this out, I can describe that mock translation service makes it so that we can test only the subject we're interested in testing currently with processor functions, but we can kind of mock, yeah, exactly what it said, right? We're mocking the behavior of the translation service, so we don't need to actually make a call to have, is there a translation service?
Right. The idea is we can run this test completely offline, right? In a plane if we want to, in any area. So there's no excuse to not test it. So I'm going to call it, and I'm going to call the function here. Again, that doesn't exist. I'm going to apply this word hello. This is going to mimic what it would look like when it ingests from a topic. And then I'm going to assert. And I love assert JIT because it just flows, right? It's much, I always forget what's expected and what's actual in the JN insert, so we use this one. We say result is equal to, what do I want to be equal to? I don't know, hello in ES, just 2-character code, right? Because we don't want to make a map, is what? Hold on, like that. That's what I would expect. Now, as is, when I give this to Dave to do the implementation, he can cheat, really easy. He could just have it return this if he wanted to, hard code, which is completely acceptable, right? Because the most simple implementation you can do is what we should do to start out with. The richness of our test, the incremental test, should give us coverage, which gets away of that functionality. But I'm going to kind of rope Dave into having to use this service that we're mocking. So how am I going to do that? I'm going to stub it out. So when the translation service is called, I want it to call a function or a method in there called getTranslation, and I'm going to match some stuff. So this guy is only going to give me this information back in the test context if it matches these requirements. So the first thing I'm going to have it match is the word hello. Matches. So first is the word. We're going to pass.
So this is the word hello, so it's English.
Now the language is coming from, yeah, is English, and the language we want it translated to is going to be Spanish. So if it matches that, then in my test context, the mock will return just the word, right? Just the word. And then to verify that this method is actually being called, I'm going to actually try to verify. So verify.
So Spring Boot kind of automatically injects this translation service, in this case, a mock bean, into the processor function. So this is going to force me, it never makes it easy for me. So he's forcing me to call the translation service, so I can't just hard code this string and return and pass the test, which mechanically we build it up that way, but since we're lack for time,
Yeah.
This guy.
There. Okay. So we've got the verified notes. I don't care what the parameters are for this. I just care that we're calling it at this point. Since I'm stubbing the return value and the input value, I don't really want to check that. So I'm going to do a few more things to get ready to fix this up so Dave can do an implementation. I've got this processor function class doesn't yet exist. Let's go ahead and create it from our IDE. I'm going to put that in the main package here. Yeah, fix that guy. But I have another error right here. It can't auto wire, right? Spring doesn't know this guy's a managed class. So we're going to go ahead and add the correct annotation for that. There's a component annotation. That clears up that issue. Yep, there it goes. And now we're going to create this class as well, the translation service. But we're going to create this in a different package for organizational structure. And we'll just create a service package. Okay, so I'm getting rid of red, right? That's my goal, get rid of red. I'm going to go ahead and close the service real quick. I'm going to split this guy. And now we're in an environment. This is pretty much what we work in all day, right? So I'm going to pass it over to Dave now, who's going to fix this test, because this guy is not going to run until you add some information. So over to Dave.
Okay, so IntelliJ is telling me here that, well, I've got a few red squigglies, right? So I can tell by looking at it that translation service.get translation is not implemented. It's even suggesting that I create the method. So I'm going to go ahead and just top down take care of these red squigglies. So let's create that method. Nice. So it creates this class for me. Get translation. I think we want it to return a string.
Yeah.
So, and then it's going to take 3 parameters, all strings. The first one being, let's call it a word. We plan on translating from English, so we'll say from to Spanish in this case. So we'll just call that to. Easy. And just to get this thing to compile, let's return a null here for now.
Remember, we're not testing the service right now. We're testing the function, right? So the service is going to be super minimal implementation. Anything to get rid of that, let's stop it.
Nice. And you can see we killed 2 birds with 1 stone on that fix. So now all I have to do is implement this translate function, right? Which is telling me doesn't exist. And so this is our Spring Cloud function. So I'm going to go ahead and create a method. Ooh, I don't think we want that return type. I happen to know we probably want a function. Takes a string and returns a string.
So when you think about the diamonds here, the generics, literally the type we're taking in from the topic is a string, the type we're outputting is a string. So that's what's called. If it was Avro data, we would have, Avro type or custom object.
Oh. Bear with me here. I'm on different key bindings. There we go. Java util function. That's what I want. Okay, so what does this look like? Well, we'll return a lambda function that takes a word and returns. Oh, whoops. Yeah.
So when I'm commenting like this, it's not because he's doing anything wrong. It's because this is what we do
this
all
is why
day.
we care.
Right. It's something like that where he could finish the entire class and not see that, and then he's too far down the road to then back up and find it. He could turn into a block.
It always kind of makes me nervous. So I'm going to cheat here, and I'm going to return this hard-coded string that we're testing for. Now, while this runs, it's going to fail, but in this case, I forgot that Cahlen is forcing me to actually use the service that's injected into the processor function. So while we wait for that to fail, I'm going to get going there. And so let's create our service method, service member here, translation service. Oh, got it. And okay,
so while Dave's doing this, I'm going to explain what's beneficial about what he's doing, both of us, right? Like the complex things, the logic of returning back to phrases, that's not the hard part. But because we're going to agree on this stuff, on all that. The little blockers when we're pairing is the nice part. Just like we have, like, oh, the return goes in front of that, or you're missing a semicolon. It's not auto-wiring this stuff. Big different comment like that to speed us up.
Yeah, so I've just, we're going to call the service. We're going to expect a string translated word, right? I'm going to give it the word it's passed in.
Yeah, you can put something on the backspace maybe.
Oh, yeah.
I'm gonna, while you're doing that, I'm gonna do this to make it a little bit more beautiful.
Cool. So get translation takes a word and it takes a from language and a to language that will represent as variables. They don't exist yet. And then the processor function. So this translate function is actually responsible for returning a phrase, right? So let's build that phrase. And let's say it looks something like word is just like the string below.
Again, and we're using string concatenation here. Probably not the preferred way if we're dealing with a huge volume of data, because we could have some memory issues. So we probably replace that in the future with a string builder or a custom something. But again, the whole name of the game in pairing a TDD is agility. How can we get value back as quickly as possible?
I'm going to go ahead. I think it'll be nice to log here. And so here's some of that free functionality that we brought in from Spring Initializer, where I can just literally add an annotation for SLF4J, and then I'm logging it. So let's just log the phrase, and then let's return the phrase.
And before we do anything, let's check to make sure this is structured right. I think there was something right. Yeah. So hello is hello in.
Hello in. Oh yeah. Hello in.
Okay. And then maybe between these two we do like an is.
Yeah, that's a little bit. Yep, this is why we. Boom. Okay. Yeah, I think that looks good.
Yeah.
And then we can see some red squigglies, so let's knock these out here. So translation service, we're having trouble injecting this, not AutoWire. Okay, so I know why that's happening. That is happening because this is not yet recognizable. Let's.
Again, and we're using another annotation here because we're injecting this class into another class, this constructor. That gives us the ability to really decouple these things and do a lot of good testing, but it has to be managed by the framework, right? And that's what those annotations give us.
Cool. Yep. Perfect. And then I see from and to are not yet defined. And so we're going to, those are configurable values. So we want to be able to configure those external to this application, right? So I'm going to bring in, use the value annotation here.
So far, we only have one test inside the function that brings back a Spanish translation, right? But the service should be able to handle multiple translations from English, whatever translated languages that you got. So in this case, we're going to test it for a little bit more. What Dave's doing right now is we're saying if this key is defined in external configuration translation service.2, then it's going to take the value of that, automatically inject it into this variable within this class for us to use.
Yeah, and I'm also giving it a default value.
Yes. In this case, if Dave didn't give it that default value, and someone tried to spin up an instance of this application either locally or else in the platform without that defined, it would give us an exception. Quick.
Yeah. Yeah, so just to make our lives easier for the sake of this presentation, I've defaulted, so we're translating to Spanish, and we are translating from English, right, which is what we've shown so far. And then another, we fixed all the reds errors, so we're good to go with one other exception.
What if we, before we do that, what if we run this guy while you're having that?
Oh, yeah.
So we're going to have the test running because of time while that's happening, and then he's going to add something else.
Yeah, so we want this is Spring Cloud function, right? So we want this function to be recognizable and injectable by Spring. We do that using the bean annotation. And then we also want this to only be recognizable in what we would consider a production use case, so that it's not actually running on a test run. So for that, we want it to be conditional on the existence of a property, and that property is its name. Oh yeah, name, and it is string cloud function definition.
Yeah. So for those not aware of the framework, a bean in respect to string is an instantiated object. Like the class has been instantiated, but it's managed by the string container. Cool. Right? The test passed. We had the annotation. We're done with this class, right?
Yeah.
What do we have to move on to next?
I think we're at a good place. Well, actually, so far we've only mocked the service.
Right.
So now we can integrate service and kind of test at that lower level.
So we're going to create a new service test here. Remember in the last one we mocked the service, right? This one we're not going to mock the service. We're going to have a call out to the real API. So at this point we're going to switch. Dave implemented and passed our last test. Now he's going to write the new test and then I'll do the implementation. Let me get it a little bit so you can see.
Okay. Yeah. Okay. So the translation service test. We want this to be context Spring, so we'll make it a Spring Boot test, and we're going to test the real life service. So this thing's going to make a call to the translation service, and so I want to auto wire this class in. So we're not mocking it. Auto wired, and let's say private translation service.
Just a reminder on mock, right? It's just a null object. It does nothing. It just intercepts the object in runtime, makes it null. The only functionality given back is what we give to it. That's what we call stubborn.
Yeah, so say given English word returns Spanish word.
Right. The function that we test is returning the entire phrase. The service is just returning a single word. So we make that pretty descriptive inside of the test.
Big translation, let's say hello, and from English to Spanish. Right, semicolon. Okay, and then again, we're going to assert that result equal to. I happen to know this one. It's going to be hola.
So before he even runs this test, I can automatically pass it really, really easily. And this doesn't make sense to a lot of people, but this is where we start gamifying this, going back and forth. I say, all right, Dave, you've got a test for me. I can pass that pretty quick.
Oh man, too easy.
Right. So again, the simplest implementation is the best. If we have good tests, that hard coding will go away.
Yep.
Right?
Yep. So now my only option is to force you into a better implementation. So I'm gonna copy this. Something.
Don't do it. Don't do it.
Yeah, I'm doing it. So when I give you an English word now, let's make it return a German word.
Okay.
And so what's that? D for the two.
How do you say hello in German?
Hello.
Hello.
But like,
I'll follow that up.
More anger.
I'll follow that up with a super.
Hello. All right. So we've got.
Awesome. So this is definitely going to break, right? If we run this test now, this will never come back. Remember, this assertion will never pass because I've got this hard-coded feature here. So I need to then inject our client, right? This is a managed bean by Spring, so we're just going to we're going to create a constructor. Public translation service. I saw it somewhere. There we go. I'll kind of move this over a little bit more. And again, usually our font's not this big, but we're doing it pretty good. Usually we can see everything on the screen.
I was also thinking how happy I was that we're using this IDE instead of like Vim or Emacs.
Oh, I wouldn't do this if we had to use Emacs or anything. IDEs have gotten a lot better since the late 90s. So word from two, I'm just going to pass those directly to the client here. That could resolve fine. Let's go ahead and run this real quick, even though we already know it's going to fail again. But this time the failure is kind of interesting. So I want to talk a little bit about pairing while this is running. The benefits of pairing. Say I'm a super experienced engineer and I'm pairing with, what kind of person would I pair with? Like if I'm a super experienced engineer, I could pair with another super experienced engineer, right? And when I'm writing code, I'm teaching that person. So I'm identifying or putting a spotlight on the brain where I need to get better and improve. And that's even more apparent when you're pairing with someone more junior. So generally, in a good pairing scenario, we would never have two junior people pairing together because they could spin their wheels for a long time. We'll set it up so it's beneficial to everybody. Good, we got a good assertion back. We're actually getting a word back, but it's not matching what we expect, right? Well, I can fix that.
We assume the translation service knows more than we do about the correct translation. I think that is correct. It's the term category.
Yeah. I mean, probably is, but this is a processor application, not one of these things. So great, this is going to run. While this is running, directly after this, we're actually going to run this application locally, right? So this is the cool thing, right? We've got it tested. We built the application just using tests, right? We haven't actually gone into a class and written out code, and then backfill the test out. Test, code, test, code. And so if that's beneficial, and we think it is, then this guy should run at this point, right?
Test pass,
Okay, great, test pass. So we have a structure that kind of looks like this now. We have a function class, we have a service class, the function calling the service. Here it's calling out to the client. Now, at this point, if we got ripped off into, say, a production incident and had to migrate this code over to another pair, everything is fully tested. That's super nice. Like I don't like when somebody gives me some code to work on and says, here's some code, but oh yeah, you have to backfill 100% of the tests. That's no fun. So as we build those tests, as we write the code, super helpful. So if we want to run this now in person, we're going to again run it through the IDE, but there's a couple things that we do have to point out. Number one is we have this properties file right here, right? This is the glue between the application and the cloud native stuff. So when I run this locally on my machine, it's going to consume messages from Azure Event Hub and then produce messages back to Azure Event Hub, right? Without this being in the cloud, but we're utilizing the cloud infrastructure around it. To do that, make that glue happen, we have properties files that look very similar to this. So I'm going to get this started. We'll come back to this and do this a little bit more explanation on that. Let's get this running. Before I run it, to bind to this property profile, I need to make sure it runs with the local profile, right? So if I go into my IDE and I look at my application here, I can see the active profile here is local. Perfect. That's all I need. Let's run it.
And so we have a source application already deployed and running in the cloud.
Yeah.
And that's getting an API to get a random word.
Right.
And it's putting that random word in an input topic.
Right.
And then we're going to run this processor locally.
100%.
It's going to, so basically we've created locally what we will deploy to the cloud, but we're able to run it on this machine.
Yes. Now, so give us another hour or two, right? And we would create a Docker scenario for this where ideally we have a complete pipeline end-to-end, mimic all the services mimic with Docker containers, but then we have always a combination of unit tests, integration tests, end-to-end tests, and everything that we write, we can write, we don't need internet connection for that, right? We can run everything and test everything locally. Super cool. So this is what the configuration looks like. This is right now currently in a private GitHub repository. Azure Spring Cloud makes it super easy for us to deploy a config server. The config server points to the private GitHub repository. My application can then bind to that configuration, right, and ingest the details of this. So when we're looking at like the connection string or the secret key, that's why we're not showing the profile here because I don't want those on the video. But those are encrypted inside of cloud configuration, right? Which means I have one code base, but I can change my configuration to change the functionality of the application from language, right? Translation to what topics we're hitting, even what middleware we're using. We could change this out for Kafka, RabbitMQ. We would have the same exact behavior, same code base.
And we could even just have copies.
Just giving you a heads up, 5 minutes left.
Oh, thank you.
Cool, yeah. So multiple copies of that file could exist with different values for different environments.
Right. So let's stop the application here. It's running, and we can see while we're talking about that, we've actually got some good stuff back. Now, is this correct? I don't know Spanish, so I don't know.
It's pretty good.
I don't know what that means either. Right? I'm assuming that's right.
Lagered, maybe there just isn't a translation.
I don't know. But we said we could also do it in German. Let's change the language real quick.
Okay.
And how would I do that? I'm going to give some program arguments. Translation service from English, translation service to German. Let's apply it again, and then let's run it.
And can we look? Do we have anything in the cloud to like display our architecture?
Yeah, so we do have an application running in the cloud because we kind of knew through our practice runs we're going to run out of time at this point. But we want to show you some details, at least of Azure Spring Cloud, that we like a lot. So this application that's currently running, this is your panel, right? One thing I do have to say, congrats, kudos to Microsoft for having a responsive UI as opposed to some other cloud providers. So that's our event hub. Let's go into the managed service real quick. So, well, we'll go into the insight. How about that? So this is a dashboard. All the metrics, everything that's wired up, those initial dependencies I talked about in the build that were commented out, those are then uncommented, pushed out to this cloud with a single line, which we'll also show you. But without configuration, the registry, the tracing, the observability, actuator, the help, everything hooks in automatically. So I can actually get a default dashboard that has some rich detailing, right? Not only do we have, a dashboard like this to build manually in an alt stack, we know from experience takes some while, right? So having something like this out of the box is very nice that we can customize. But we've got a few things on it that we can check out. We can go to live stream right here, and this is going to show live metrics from our application. And we can see those starting out. So the cool thing about these live metrics is, too, we can apply thresholds to these, right? So if we need to do auto scaling or send alerts, if we run into exceptions, we can have those all triggered by this. And we don't need to do anything except build the conditions for these alerts, right? And lastly, a visual view, right? I want a visual view of what's going on. Very cool.
That's awesome. So all of this is basically out of the box because we brought in those 4 dependencies.
Right, those 4 dependencies. Zipkin, Sleuth, etc. Now, why are we using this instead of a streaming platform? Let me give some insight to that specifically. A streaming platform is nice. We've used things like, Lightbend, Spring Cloud Dataflow, Storm. You name it, streaming platform, we use it, right? However, someone's got to be in charge of that infrastructure. Someone's got to make sure that cluster for that streaming platform is highly available, all that kind of stuff, right? I don't want to do that, right? I just want to build my application and get value back from it as soon as possible. So using a managed structure, this is very nice for Spring applications, but we can do the same thing with Kubernetes, same thing with Cloud Foundry, Tanzu, etc. We don't need an entire platform because what is a data pipeline other than kind of a guided path to microservices, right, in the middle of it. So,
awesome.
Yeah, after that guy, let's take a look at some logs here because we said this guy was running in German. Looks pretty German to me. If it doesn't have a German translation, it comes out with just the normal thing. So
Leopards is leopard.
Perfect.
That's awesome.
Right. So, yeah, and in the cloud version, to deploy that out, it usually takes about 5 minutes to deploy because it has an automatic blue-green deployment, but this is what that string looks like. I use the Azure CLI, the Spring extension. I just deploy it with the name service. I think that's our.
Oops, that might have been okay.
So just to wrap up, I know we went through a lot of stuff. We tried to do some live code in here. Everything that we've done today will be available in the repo above here so that you can look at it in more detail. And then, of course, our website if you want to learn more about what it is and what we do.
Thank you.
Thank you, Cahlen and Dave, for your presentation and for any questions that may come up to you guys in the future from this presentation. You can contact the speaker directly if there are any further questions. Please provide your feedback using the form provided in the chat box. And thank you again, everyone, for joining today's presentation. I hope you have gained some insights from the session. Have a wonderful day, and thank you for being a part of this year's DataCon LA.
Thanks,
Thank
Eli.
you.
Thanks, Lori.
Thank you, everyone.
Thank you.